Hi friends, welcome to Python Programming with Akash. I hope that you have been doing well. We will be learning about Python, but before starting that, there are a few terms related to programming that we should be aware of. So let's take a look at them. So the first term that we will take a look at is a program. So what is a program? A program is basically a set of instructions that we give to a computer to perform a specific operation. When the program executes, raw data is processed into a desired output which is presented in a particular format. We write programs in a programming language which are generally high-level languages, but these could also be written in assembly language. We also refer to programs as the source code. Let's take a look at the next topic, which is types of programming languages. At the top, we have the high-level languages, followed by assembly language, and then at the bottom we have the low-level language. The high-level languages are the closest to the user or the programmer, and the low-level language is closest to the computer. Let's start with high-level languages now. These languages are nearly human languages, which essentially means that words from the normal languages like English and others are used as it is in these languages. For example, C, C++, C#, Java, Python, etc. We generally write our programs in a high-level language which is almost similar to human language. These languages are portable, but interpretation or compiling is needed to convert them into a machine language which is understood by the computer. Next, we will discuss the low-level language or machine language. The language which can be understood by the computer is called the machine language or the low-level language. It is also called binary language as it consists of only zeros and ones. Next, we will talk about assembly language. Assembly language lies between high-level languages and machine language and is also known as symbolic machine code. Assembly language depends upon computer architecture. Assembly code is converted into executable machine code by a utility program that is known as the assembler. Now let's talk about source code. Basically, the program written in high-level language or assembly language is referred to as the source code. It is primarily used as input to a process that produces an executable program. That is, it is given as an input to an interpreter or a compiler which interprets or compiles it and thus converts it into an executable program. In computing, source code may be referred to any collection of code, possibly with comments, written using a programming language that is human readable, usually as plain text. Computer programmers specify the actions that they want a computer to perform, mostly by writing source code. An assembler or a compiler are often used to convert source code into binary machine code that can be executed by the computer. The machine code thus generated might then be stored for execution at a later time. Alternatively, source code may be interpreted and thus executed immediately. Next, we take a look at what is object code. Compilation of the source code results in object code. Object code is also made up of binary language and therefore consists mainly of the numbers zeros and ones. It cannot be easily read or understood by humans. Object code can then be linked to create machine code or executable file. This machine code runs to perform the specific program functions. Next we see what is machine code. Machine code is binary code, meaning ones and zeros that can be directly executed by the CPU. If you were to open a machine code file in a text editor, you will see garbage, including unprintable characters. Object code is linked to create the executable machine code. The next topic that we look at is the assembly code. Assembly code is plain text and somewhat human readable source code that mostly has a direct one-to-one analog with machine instructions. This is accomplished using mnemonics for the actual instructions, registers, or other resources. Examples include JMP and MULT for the CPU's jump and multiplication instructions. This is nothing like machine code. The CPU does not understand assembly code. Assembler or compiler is used to convert assembly code to machine code, though we usually think of compilers in association with high-level programming language that are abstracted further from the CPU instructions. Now let's take a look at the complete process from writing the source code to generation of the executable machine code. To build a complete program, we first write the source code for the program. That source code can be written in either assembly or a high-level language like C++, etc. Then we assemble the source code if we have written it in assembly language. But if we have written it in a high-level language, then we compile it to generate the object code. Individual modules are linked together to generate the machine code for the final program. In the case of a very simple program, the linking step may not be needed. In other cases, such as with an IDE integrated development environment, the linker and the compiler may be invoked together. In other cases, a complicated make script or solution file may be used to tell the environment how to build the final application. There are also interpreted languages that behave differently. They rely on the machine code generated by a special program known as the interpreter. At the basic level, we can say that an interpreter is responsible for parsing the source code and immediately converting the commands to new machine code and executing them. Parsing a program essentially means separating it into more easily processed components which are analyzed for correct syntax and then attached to tags that define each component. An interpreted language may also be pre-compiled to a lower level intermediate language or bytecode similar to assembly code. Now let's talk about open source software. Most application software that we use is available in a form where only executable files are available. If the source code were included, it would be so much useful to a user, programmer, or system administrator because they would be able to study or modify the program. Cool, right? There are some softwares for which the original source code is made freely available and these may be modified and redistributed. These are termed as open source softwares. The next term that we will study is debugging. The process of fixing a bug in the software is known as debugging. In other words, we can say that it refers to identifying, analyzing, and removing errors. Whenever the software does not execute properly, then the process of debugging begins. We find the problem, analyze it, fix it, and test if the software runs properly. This process is considered to be an extremely complex and tedious task. This is because errors need to be resolved at all stages of debugging. Now, we have discussed most of the terms that we will use as we go along learning programming. I hope that you would be able to understand everything explained in this video. But in case you have some doubts, do let me know in the comment section. I will surely come back to resolve your issues. Now I would want you to do something for me. First, click the like button and second, subscribe to my channel. I will be back with more learning and more videos. Until then, stay tuned. Thanks for watching and have a great day.